All right, take two. First one had no sound. So today we're going to talk about the strategy pattern of the design patterns on the Gang of Four patterns. So the idea behind the strategy pattern is that you have these families of similar algorithms that you might want to change between, whether that's deciding which of the strategies to use come runtime, or if you just sort of want to pull the implementation of those out of your class and put them sort of somewhere else, put them in their own encapsulated classes, then you might be looking for the strategy pattern. That's the whole basis of this. So say you have a client and it uses an algorithm inside of it, but you have different versions of that algorithm that you might want to use. So for example, if you, well, in our example, we've got a student class, and that student wants to be able to calculate their final grade. So depending on the student's major, the way that they calculate that grade might be different because different types of assignments might be given different weights. So we have these sort of sets of similar algorithms, all sort of fulfilling a similar function. They all are calculating the final grade, but the way that they do that is slightly different. So the design list way of doing that is with a series of if and else if statements, or you could also conceivably do it with a large switch statement, but that's not clean, that's not tidy, and that doesn't really follow object-oriented design. So this right here is something that we want to avoid. We don't want to have this, these lists of untidy algorithms all sort of packed together haphazardly and in no particular order or anything like that. And so we've got this UML diagram of that where there are no other supporting classes, right? So the student and the major here, the major doesn't provide any functionality. It's just a set of enumerations, and so all of the responsibility for calculating anything rests on the student class all by itself. And so what the strategy design pattern lets us do is it lets us take all of these messy algorithms and all of these very similar things and pack them into their own separate classes. It lets them pull those implementations out of student. So the student class here, this is the designed version of it. You can see it's much cleaner, it's much tidier. Really the only thing it has is it has this, the algorithm that we were doing before. It's calculating the final grade, but it doesn't have any of the actual work done inside of this function. It outsources that to this GS object here. And what that GS object is that's a grading system interface. The interface itself, again, is very simple. It just calculates the final grade, but what the beauty of the design pattern is that it lets us implement that in whatever way we want across a host of different classes. So this one in particular is for if you were a software engineering major. It pulls in the grades and it does whatever fancy algorithms or calculations need to be done for that. But you also have a separate one that implements grading system, and that's for IT majors specifically, or you have one for computer science majors. And so you see, you just have to make these sort of subclasses, or you could also do this with an interface as I've done here, and they do all of the actual work of picking which of these concrete strategies you want to implement. Another great thing about this is that you can see in the student, we don't have to decide until runtime which of these different algorithms we're going to implement. So the student just calls calculate final grade on this GS object without, at design time, knowing what this G object is actually going to be. And so that lets us build a more generic student class, a more generalized student class along the lines of object-oriented design, and then decide at runtime which of these specific implementations we want to use. It's also nice because it means that you can have these sort of standalone classes which are much easier to troubleshoot and to work with, and you can add and remove classes as you need, get a sort of this like kernel-style module style way of implementing all of these different features. And so in this designed version, we can see that all of the functionality has been outsourced to this one interface. It's got this really simple way of interacting with these multiple grading systems, but then from that interface, we can have a whole host of different classes implementing that grading system in whatever way works best for the student, depending on the circumstances at runtime. So that is what the strategy pattern is used for. It's used for this encapsulation of these similar algorithms out into their own classes. So if you ever find yourself in a situation where you have several very similar algorithms all sort of piled together, you have long lists of if statements and else if statements, or maybe one giant switch, it might be time to employ the strategy design pattern.